Hello, in this video we're going to look at the meaning of the coefficients when graphing sine and cosine, but we're going to look at the effects of B and C, the horizontal changes. And by that I mean when we write y equals a either sine or cosine of bx plus c plus k, we're going to look only at the effects of B and C. Now I've split this up. There are going to be a few examples. This is going to be the first example. All right. So, and by these coefficients, I mean the coefficients that have this meaning. A is the amplitude, which gives me the distance from the max or min height of the wave from the axis. The phase shift is where the wave begins. It's negative c over b. The period is the length of one wave, which is determined by 2 pi over b. And the vertical shift is k, the new axis. In our case, we're not going to have a vertical shift, and we're not going to have an amplitude change. All right, so let's look at our first example, which is what this video is on. Y equals cosine of 3x. Okay. Now notice there are parentheses here because the argument isn't just x. Now, I could look at this as y equals 1 cosine 3x plus 0 plus 0, okay, to be able to recognize my coefficients. Now I'm going to show you two methods. Both are equally as effective. I tend to prefer this first one that I do, but really it doesn't matter. You can do it either way. So method 1 versus method 2. Okay. Now we want the argument, whatever is in here, and I usually call it stuff. I want to take the cosine of stuff that goes from 0 all the way through 2 pi, because I know from my basic shapes that as long as I go around the unit circle from 0 to 2 pi, I will generate this shape. So as long as I'm taking the cosine of values from 0 to pi over 2, right, from 0 to pi over 2, I'm going to create this first part of the graph. Then when I go from pi over 2 to pi, I'm going to generate this part of the graph. When I go from pi to 3 pi over 2, I'm going to generate this part of the graph. And when I go from 3 pi over 2 to 2 pi, I complete the cycle right here. Okay? But what we're going to find then, using this first method, is what do I have to have x be? How do I solve for x so that I force the cosine of 3x to go from 0 to 2 pi? All right? So then, therefore, I actually set 3x equals 0. And 3x equal to 2 pi. Then I solve for the x that makes that happen. So x is 0 over 3, which is really 0, right? And then here, x is 2 pi over 3. All right? So this is where the wave begins, and here's where the wave ends. All right? So the distance between these, right, the end minus the beginning, will give me the period or the length of the wave. So the period, using method 1, is end minus beginning. So that's 2 pi over 3 minus 0, which is 2 pi over 3. So my period is 2 pi over 3. Now let's take a look at the second method to get these numbers. Here, what I do is I use formulas. So I know that the formula for the period is 2 pi divided by b. In our case, b is 3. So 2 pi divided by 3. And then the phase shift, which I'll use ps, is negative c over b. So c is 0. So I basically have negative 0 divided by 3 is 0. And the end of the wave is the phase shift plus the period. So it's where I begin plus the length of the wave. That'll give me where I end. So here I'll have 0 plus 2 pi over 3, which will give me 2 pi over 3. So indeed, here's this period matches here, the end of the wave is here, and the beginning of the wave is there. So they both give you the same results, of course. Now, when I go ahead to graph this, I have no vertical shifts. I only have the horizontal shifts. But I do start at 0, so that's my phase shift. So I'm going to go ahead and do this, start at 0. And let's say I put here 2 pi over 3. Now I want to divide this into fourths because, again, still what's happening is I'm drawing this basic shape, and so I want to divide this into fourths. Alright, so there's my fourths, and I don't know exactly what these values are. We'll find them a little bit later at the end. So I go from 1 to -1, and with cosine, I start at the max, right? It's not reflected, so I start at the max, go down to the axis, which is a 0, then go to the min, come back to the axis, and go back here. So here is the basic shape for that. Well, actually the shape for this one, sorry. Now, let me go ahead and talk about how do I figure out these values in here, all right? Well, the idea is the period is this distance that it took me to see one wave. I went from here to here, and that's a distance of 2/3, but I'd like to divide that distance into 4 equal parts. So what I do is what I call the quarter points, and I abbreviate that QP. I want to take one, I want to divide the period, divide it into 4 equal parts. All right. So in our case, that's 2 pi over 3 divided by 4, which can be written 2 pi over 3 divided by 4, and that's understood over 1. Flip and multiply, and you could say 2/12, or you could reduce 2 goes into 4 twice, however you want to do it. Let's say I do 2/12, 4 pi over 6, right? So now I know that each quarter point is going to be pi over 6, an additional length of pi over 6. I could have also said, well, I'm going to take 1/4 of the period, okay, which is 1/4 of 2 pi over 3, which would kind of get us right here in this calculation. And then I'd say 2 pi over 12, pi over 6. So however you want to think about it. But what that means is, this. How do I use this pi over 6? Well, it means that when I start, whatever value I start at, in this case I'm starting at 0, I want to add pi over 6 to get this next value. So this is pi over 6. Then I add another pi over 6 to get 2 pi over 6. Then I add another pi over 6 to get 3 pi over 6. Then I add another pi over 6 to get 4 pi over 6, which reduces to 2 pi over 3. Okay? So let me go ahead and just redraw this so you could see, then we can label it a little bit more nicely. I go from 1, -1, and let's say here. So I'm at, let's see here, 2 pi over 3. And let me go ahead and reduce these. This is pi over 6. 2 pi over 6 is pi over 3. 3 pi over 6 is pi over 2. And then you have 2 pi over 3. So we begin here, the max, go down to the axis, come to the min, go back to the axis, and go back to the max. And I fill this in. I would label my points here. Do that with a different color here. I'd say this is 0, 1. This is pi over 6, 0. This is pi over 3, -1. This is pi over 2, 0. And finally, 2 pi over 3, 1. Okay. So that's one full wave labeled. I'm going to go ahead and extend this and go through 2 pi. And let me just make sure we've covered. Oh, and have I actually done this? Ah, I see. And perhaps, well, I think if you need to write these out, it might be a little bit beneficial to write those out. Let me just show you how I normally do this too. I say 0, the starting point, and I add pi over 6 if you want to do it the longer way, pi over 6. Then I take this value, right, and say pi over 6 plus another pi over 6. That's 2 pi over 6, or pi over 3. Then I take this. I keep it in pi over 6s because that's what I'm adding as 1/4 of the period. So 2 pi over 6 plus another pi over 6 is 3 pi over 6, or you could say pi over 2. And this comes back over here, 3 pi over 6. plus another pi over 6 is 4 pi over 6, or 2 pi over 3. And that's our check in the sense that here's where we end. We know the wave ends at 2 pi over 3, and indeed that's what we got. So that's a nice check to have that happen. Now, the other thing I want to show you is, how do I continue drawing this wave? Well, what I see is that the period, right, is 2 pi over 3, this distance, from beginning to end. So all I have to do, if I added another 2 pi over 3, right, I'd go from 2 pi over 3, let's go ahead and put this in here. If I did add another wave or cycle. So I'm at 2 pi over 3, and I know I want to add the period, which is 2 pi over 3 plus another 2 pi over 3. And that's going to be 4 pi over 3. So what that means is, visually, I can kind of say, well, it's about this distance, so I'm going to be about here, just to be kind of accurate here. This is going to be 4 pi over 3. And I don't really even, I mean, I can if I want, label the points, but let's go ahead and just draw this out. I know this is going to be split into fourths. I'm going to start at the max, go back to the axis, go to the min, go back to the axis, go back to the max, right? So here's my wave. Okay. And now if I want to do another wave, I would add another 2 pi over 3. If I want to go backwards, I subtract 2 pi over 3 from this endpoint, from the x value of this endpoint, which is 0. So I'd be at negative 2 pi over 3 going that direction. Going this direction, 2 pi over 3, well, I ended at 4 pi over 3. I add another 2 pi over 3. So add another cycle or wave. I'm at 4 pi over 3 plus the period, which is 4 pi over 3 plus 2 pi over 3. That's 6 pi over 3, which is 2 pi. Okay, so over here, I would say, try to kind of guesstimate it pretty nicely, right, about here. So I'd say, oh, okay, this is about 6 pi over 3. Divide that into fourths, and really I probably want to say 2 pi. Right? And then I'd say I start at a max, go down the axis, go to the min, go back to the axis, and here, and go ahead and fill that in. And one thing you should notice then is that from 0 here, all the way out here to 2 pi, right? That distance of 2 pi, I have 3 waves. 1, 2, 3. And my original function was cosine of 3x. And that 3 corresponds to the fact that I have 3 waves in the same space that I used to have, or same distance, that I used to have 2 pi. So the idea is, the original period was 2 pi, and now I basically would, because b is 3, it only takes me 1/bth of the original period to see one wave. And that's the 2 pi over b. All right, that's the 2 pi over b that you see as the formula for 2 pi over b is the period. Okay. All right, and then if you wanted to continue adding values here, we found, remember, that the quarter points were basically a quarter of the period was pi over 6. So you could just keep adding pi over 6. This was 4 pi over 6. This would be 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6, which does indeed correspond to 2 pi. So this would be relatively easy to fill out. And you can just keep going on and on in either direction. All right? Thanks so much for listening. Oh, one last comment. Let's see, the amplitude here is 1 because it's the distance from the axis to the max, or from the axis to the min. You have a distance of 1, that's the amplitude. All right, and the phase shift is 0, and the vertical shift is 0. Thanks so much for listening.